talk in general about transformations, and we're going to use kind of the official terminology and vocabulary, but you guys have some knowledge of it. So what we'll do right now is we're going to refer back to, like, think about that absolute value investigation we did and how you thought about A, H, and K. Okay? So we're going to talk specifically about 3 different kind of categories of transformations. There's translations. So what is translating? Shifting, okay, left and right. There are reflections. Okay, yeah, so like flipping over, okay? And those can be vertical, like from up to down, or they can be horizontal, where you kind of flip over the axis of symmetry that way, okay, from left to right, right to left. Okay, and then our third category is going to include stretches and compressions. So before, that's when we talked about, oh, is it wider, is it narrower? But there are vertical stretches and compressions, and then there are horizontal stretches and compressions. And we have to separate all of these different ones, okay? So the first transformation we're going to talk about is the translation, so the shifting, okay? So the first one we're going to look at is translation. Yeah, so this is on the back. Just start at the top, and we'll work our way down, okay?
Like top left corner?
Like top, and we're gonna write across so it can go across the paper, okay? Yes. No, just shut the doors and turn it over, yeah. All right, so first thing is translation. If you're going to struggle with what translation means, remember that this is like shifting, okay? Okay, or sliding the graph. But you're going to use the vocabulary now of translation, okay? So what are the different ways that something could be translated? Sure. Good. So it can go left, right, or up, down. So we break them into 2 categories. The horizontal ones, so which ones move it left and right, and the vertical ones, which ones move it up and down. The reason those 2 separate categories is if you remember in your absolute value function, what did the H do? Left and right, right? Depending on the H value, it either moved left or right, but that one number controlled any horizontal translations, okay? What did the K value do with the absolute value function? Up and down. So that one number controlled any vertical translation. So they don't come in 4 categories. Oh, this one left, this one right. They come in 2 categories. Left and right, up and down. Horizontal and vertical. Okay? So we're going to use function notation. So we're basically thinking that we're starting with a function called f of x. So I'm not telling you if it's an absolute value function or a quadratic function or a linear function. I'm just using its name, okay? So in the absolute value function, if we wanted to do a horizontal translation, okay, was it the h or the k? We just talked about this. The h. Was the h inside of the absolute value function, or did the h happen after the absolute value part was done? Inside. The stuff that is inside whatever function you're working with would be the stuff in the plugging in area. It would be in here with x. It would happen before you did whatever it is that you're doing, absolute value, squaring, square rooting. Okay, it happens inside of that thing. So for us to make any sort of horizontal translation, there has to be that h value that happens inside of the function. Okay? So the way I would note it with function notation is I would write it like this, that something is happening inside that special part where you plug stuff into the function, and I would write it like we saw it before, like an x minus h. Okay? So again, what is this? This is going to be a horizontal translation, which means either left, I totally drew the arrow the wrong way, right or left, okay? Depending on what the value is. So an example of this, if you don't like the function notation, we do have to get used to it. But just to give you a little example, let's say your original function was the absolute value parent function. Okay. And let's say I wanted to shift 3 units to the left, what would my new function look like? I want the absolute value, but I want it to be 3 units to the left. Damien? Good, because we do like the minus h thing, right? Okay. And so if somebody asked me to describe the transformations of this function from the parent function, this is the parent. And the transformations that I would see here is I would list this as a horizontal translation, 3 units to the left. So it's still nice to know the amount and the direction, 3 units to the left. That part's not changing. The vocab part here is that there's a horizontal translation taking place in the graph. Is this all right with everybody? Okay. So for any graph, quadratic, cubic, a square root, anytime inside of that thing, underneath the square root, it said x plus 3, guess what? That graph is getting moved 3 units to the left also. Inside the perfect square, it said x plus 3. That graph is getting moved 3 units to the left also. The cool thing is once we learn the transformations, they're the same for all different families of functions. We just have to learn how those ones are structured at the beginning. Okay? All right, so there can also be a vertical translation. How do we think a vertical translation is going to compare to how I noted the horizontal translation here? So what moved our absolute value function up and down? The k value. When did the k value occur? Within the absolute value or after that calculation was done? After that calculation was done. So the notation would look a little bit different. You would have your parent function, and you would still do the absolute value the way that you always did. And then after that part of it was done, you would then add your k value. So see the difference in the notation? Inside the function is a horizontal translation. If it's happening after the important part of the function, it's a vertical translation. Okay? So this is a vertical translation. So moving something up or down on the graph. And again, for an example of this, if we stuck with our absolute value parent function, there's our parent function equation. The difference is we would do f of x, and then the plus 3 would be outward, so this would be the absolute value of x, and then plus 3 outside of it. And what would this cause to happen to our absolute value parent function? What translation would occur? Good. Up and exactly 3 units, because that's the number I use. So this would be a vertical translation. And it would go 3 units up. Sorry. Are we okay with translations? So any questions about translation up here? All right, I started with that one because that's kind of the most basic one and the one that was easiest to see demonstrated in our absolute value function. Okay. The next one we're going to talk about are reflections. Okay? So just like here, how there was a horizontal and a vertical, there's also a horizontal and a vertical reflection. So the second type of transformation we could talk about is reflection. It could occur in our graph horizontally or vertically. Sometimes it matters and sometimes it doesn't. What's an example of a graph that if you reflected it horizontally, you wouldn't even see the difference? CJ? Okay, so an absolute value graph is an example because if our axis of symmetry is going like this and I reflect it this way, would you even know that I reflected it? No, it would look the same. Okay? Okay, so anything where the axis of symmetry of the parent graph is the y-axis, so anything that cuts in half, so like a parabola too, right? If I reflect it that way, you wouldn't even know the difference. Okay? Good. A horizontal line would be an example. If I reflect it, you don't even know that I reflected it, right? Okay, so there are some cases, it doesn't mean it's not there. It just means that when you graph it, it doesn't make a difference in where the points lie on the graph. Okay? So how do we recognize if it's there or not? So for reflections, so our second transformation, we're going to list our reflections. So if I wanted to reflect the absolute value graph horizontally, even though it doesn't change, what used to be at the x-axis at 1, so you don't have to write this part down, but think about this. So this point that used to be on the graph lined up with the x value of 1, if I'm reflecting it horizontally, I now want this point to move to the other side and be lined up at the x-coordinate of -1, right? Basically, it's like you want to take a positive x-coordinate, you want to flip it over to a negative x-coordinate. If it had a negative x-coordinate, you want to flip that over and make it positive. But it would all be about interchanging the x-coordinates, right? It would stay at the same y level or the height. It would just switch locations to the positive or negative x-coordinate on the other side. So it's the x that's receiving the change when we flip things horizontally. So again, for reflections, how did we reflect an absolute value graph? What showed up in the equation that told you it was reflected? Good. Okay, so a negative shows up somewhere in the equation, right? So to tell if it's horizontal or if it's a vertical reflection, it's where the negative shows up. If the negative shows up inside of the function, okay, meaning it's affecting the x. It's not happening after the absolute value is done or after the squaring. It's happening inside that absolute value or inside that squaring, okay? This is a horizontal reflection. And remember, that means that what was on the left will now be on the right, and what's on the right will now be on the left, okay? Flipping things over that way. So an example of this, let's say we had a cubic as our parent function. So a cubic looks like x cubed. This would be our parent. Actually, you guys are going to hate me. I don't want to use a cubic for this one. Sorry. It's a better example. We can use this one. You'll see when we learn what it looks like why it's not the best example. I'm going to use a square root function. Square root of x. If I wanted to see a horizontal reflection, that means I want to apply the negative within the function. I want the negative to happen to x before I do the special thing that I'm doing, square rooting or absolute value or whatever it is. So it would look like this as a horizontal reflection. Okay? Is this all right with everybody? When you think about it, what numbers can you plug into this original parent function? What numbers can you plug in and get a result? What x values are in the domain? What's okay to plug into this function? 0 and can I plug in -3? Not if I want to get a real answer and graph it, right? So the domain of this function is 0 and beyond 0, right? So things greater than or equal to 0. Is that the same domain as this function? No, you can still plug 0 into this one, right? But can I plug positive numbers into this one and get a result? No, what kind of numbers do I have to plug into this one? Negative numbers. See the reflection? Before you could only plug in positive stuff. Oh, now you can only plug in negative stuff. So the graph is taken from this side and it's reflected over to this side. Okay, that makes it a horizontal reflection when we apply the negative inside of there. Whereas if we see the negative applied like we did in our absolute value function, we didn't ever see the negative inside the absolute value. We saw it outside of the absolute value and it caused it to go from up to down. That's a vertical reflection. So if the negative is happening, but it's happening after all the special stuff that the function is trying to do is done, it's going to be a vertical reflection instead of a horizontal reflection. Is this okay? All right, so an example looks different if we kept our same parent function that we talked about with horizontal reflection. So again, we can only plug in positive x's. And guess what we get out? We only get out positive y values when we plug in x's, right? Like the square root of 4 is 2, square root of 0 is 0. So we're just going to get 0 and positive stuff. If we do a vertical reflection, which means we apply a negative, but outside of whatever the function is, so we still have our square root of x and the negatives out here, okay, we still plug in positive x's. So it didn't change it from the right to the left. Okay, we still plug in positive 4, 0, stuff like this. But when we plug in positive 4, we don't get positive 2 now when we take the square root. We get positive 2, but then we put a negative in front of it, which makes it negative 2. So before, we were plugging in positive x's, and we were getting positive y, so our graph was going somewhere up there, right? Now we plug in the positive x's, but when we get the y values, they all get turned negative, so the graph goes down here. So it got reflected from being above the axis to being below the axis. That's why it's a vertical reflection, up to down or down to up. Okay? Is that all right with everybody? Yes?